What's up, everybody? And today we're gonna continue doing LeetCode and I prepared a few problems and then we're gonna do LeetCode together. How it is awesome! That sounds so awesome, right? 435 non-overlapping interval given an array. Okay, first understanding the question. It's very important to understand the question in order to do the question, right? Okay, for the question, then it says that given an array of interval and then return the minimum number of interval you need to remove to make the rest of interval non-overlapping. Okay, at first for this kind of problem, immediately you need to realize that it's a greedy algorithm basically, and yeah. And then, wait a second. I think I know this problem. This problem is just a simple greedy. It's like, I remember like learn this from. It's called task scheduler. So it's like a general problem that both have similar setup, and for this problem, it's a greedy problem, and how to solve it is very simple. Sort it. Oh, so firstly, since it's greedy, then you have to how to say it's like if there's a greedy algorithm, you always make the best decision, and the best decision you make is for this question is that first you sort it by the first number, and then you choose greedily. What that means is that if there is two calls start at the same time, then you always choose the one ending sooner than the other, and then it's like always the best choice. And so it's what we're gonna do now. So we're gonna do a sort, building sort. Oh wait, let me do it in JavaScript because I'm more confident in doing this in JavaScript. And yeah, I do that. So we do a sort. Wait a second, is JavaScript sort? I think it's like this, and then we give additional lambda like function, and then here we just simply return a0 minus b0, which is we sort it by the key at index 0, and then let's print it out, which console log the intervals and see if it does the job, and run the code. Awesome. And here we're gonna do a sort of sorting, and how we're gonna do that is that we can simply let new a, which will be our new arrays variable, and then we do a for of loop. Yeah, let's do a for of loop. That I equal to 1, I smaller than intervals dot size. I mean not dot size, dot length. Okay. And then plus plus. And here we actually wait, should I do that? Actually sounds bad. I should start with 0. What I'm thinking right now. So okay, and then also need to we need to ensure that no conflict, basically no conflict. If there's no conflict, then we can move it in. If there is conflict, then we will not move it in. Wait a second, I kinda so let me resemble the detail for the sorting algorithm. I remember the first day to sort it by the key 1 and 2, and then what should I do? Wait, that's sorting by key 1 or key 2? For this one, I'm actually not quite sure. Should we? I think it's ending. Then yeah, we should sort it by end, and then we just choose the one that no conflict. Yeah, and then we can here let current write max equal to 0, and then we sort of move it. I guess we can do that, and then if so, here's the case that suppose that our new intervals at position I one is greater, it's like smaller than current max, then we have to ignore it. Oh, here, let's just remove this. We have to remove it, and here we can just use a counter to do the job, I guess. So let's declare a counter variable here, and then if suppose this interval at position I, and the second index is smaller than current max. A second, let me think about this. Actually, so yeah, I realized so what I'm thinking right now is that we also need 0 to be smaller than current max. Actually, I'm not sure about this one, but I'm going to keep it anyway because why not? And what that means is like since the current right max is indicating the it's like our boundary on the right hand side, right? But since each element in this intervals represent the intervals, but we need to ensure that either the right this interval would be like this will, and our current max might be positioned like this. So what we need to do is to ensure that both like this interval completely is like completely not intersect with our boundary. So make sure that works. So like this, then it doesn't work. But if my boundary is here, then this 3 is like completely on the right hand side of my current max, then it should be greater. I think I made a mistake here. And oh wait, here I want to eliminate so it's like correct. So here like if it's more than current max, then we can just let it go, I suppose. But wait, let me think about it. So here like 2 is 2 allowed. Oh, that's an interesting question. So starting and to be like 2, it is allowed or not? Technically it's not overlapping, right? 2, 2, 3. Wait, like. That's interesting. So I think that to do with this problem is like so what I'm seeing right now is like 1 to 2 obviously means from position 1 to position 2 and 2. Oh right, oh, never mind, stupid question. So 2 to 2 in mass interval, since it's just a print, so it doesn't represent any interval, then obviously it wouldn't be overlapping, so I'm worrying too much about it. So here, suppose this happens, then we just counter plus plus, and else we update our current right max, and this will be our new boundary. And I guess that's it. And then we can just return counter and the problem being solved. And I think this problem is called hash schedule. Oh, it's 0. Okay, it's not quite correct right now. Okay, let's think about why it's not correct. Right max. Suppose oh, shall be all. Stupid mistake. Cool. And try another input, and it seems working. And I don't know. I just try more input and see if it's still working. And also, the sorting part will be O(n)log(n), and this part will be O(n), so that it can be satisfied this boundary. Although, I just want to try something big, like 0. Oh, should be 199. Oh crap, it executed. Okay, cool, it worked. So suppose that 199, and since we are sorting by the last key, so this element will be at the end, and obviously when execute to that print, then the 1 would be smaller than current max, and hence this element wouldn't be counted. Will be counter plus power, which means this element should be removed, and that's the basic logic here. And we can try more. Also, like I'm not sure about, like, let's try if the if the number is the same, okay, it have to be strictly greater than I'm already too much. And yeah, let's try some more input. Okay, but let me try something here. So suppose that I got a 1 2, I mean like 1 3, and then there is another 2 4, and then there's 3 5. Then it should be 1, right? But it's a bit trickier. And see if my program work. And my program work. Let's submit. Oh crap! Oh no way! I didn't consider a negative number. Crap! I didn't consider a negative number. I mean, does it matter? I'm not quite. Oh, so like, oh, I think its problem is here. So should be like, crap! I didn't consider about that. Just, and it should work. Yeah. So yeah, I didn't consider its negative number. So the initial value is set to be 0, which is not quite true for a negative case. But now I choose a big enough negative number and think it should work. And here we can check. Okay, it should work. Submit. Cool. And I think the speed is okay. And that's yes. Thank you for watching. That's non-overlapping intervals 435.